For our presentation, the case study that we'll be focusing on is the Quebec Bridge collapse. In this presentation, there will be a brief background of what happened, the ECAD analysis, the legal analysis, and the conclusion and some takeaways from what happened. About the collapse. The Quebec Bridge was expected to be one of the biggest engineering wonders in the world and one of the largest types of bridges of that kind. Theodore Cooper was the bridge designer and made changes mostly to the bridge's span, trying to make it longer. Robert Douglas, a Canadian government engineer, was the one that reviewed Cooper's work and mentioned that there was some concerns about the bridge stresses due to such a longer span. However, Cooper ignored these concerns and just went along with construction anyway. Structure failure was starting to become noticeable on August 6 of 1907, with lower chords bending at the south arm. The second construction was organized by the Canadian government, and the design included a heavier cantilever-armed system. However, the center span fell into the river while it was being hoisted into position. This bridge had two collapses, one on August 29th in 1907, and the other one on September 11th, 1916. Due to negligence and ignorance, Theodore Cooper was the one that was blamed for the collapse of the bridge due to his errors in judgment, safety, and bridge design, plus load calculations. It was claimed that there was professional and moral duties which were neglected in order to achieve profit. And the final construction of the bridge was concluded in 1917, a year after the second collapse, and it was opened on August 22nd of 1919, 2 years after the final bridge construction was concluded.
EGAD analysis. So some ethical issues that were found in the project are lack of funding, negligence when changing designs, we were not looking at codes and standards, rushing to meet tight deadlines, and not overseeing the actual construction and appointing unqualified engineers to oversee the construction. Some main clauses that were identified were 72.2a, b, c, and h, as there was negligence when working through the project, not safeguarding life for its citizens of the bridge that were going to be using it, and also failing to correct mistakes as there was prior knowledge to the damage, and providing work and undertaking work to people that were not competent. This can also be shown in other clauses and the code of ethics because they're not meeting their need to deal with the public. Their competence is clearly not there if they are making these types of decisions in such a large-scale project, and of course permitting other engineers to do work that they're not qualified for. So some alternative options that we came up with were halting the project when stuff happened, or working with qualified engineers to change the design, or just completely stepping away from the project because of the state it was in. So we can see option one, by stopping when we recognize there's an issue and waiting for that issue to be solved correctly, we completely abide with all the clauses and the code of ethics, and it avoids everything with the main factors that caused the collapse. Option two does have the potential to solve the ethical dilemmas that are found in this project. However, with introducing new engineers into the equation, we do now have the potential to violate other ethical codes and clauses because we're working on a large scale project. There's potential for greater conflict. We don't know how we're going to be respected or treated. Everyone's going to have a different viewpoint, and the competence of each engineer now has to be questioned. By halting the project for option three, we can see that we can potentially satisfy some of those ethics and code clauses, but we're not serving the public because we know that there's something wrong and we're not doing our part to fix it, which is a serious issue. So we decided that the first option, to halt the project when it reached the financial limitations and wait for proper funding, is the best way because during that time period, we would make sure that we are hitting the most important parts of the project. We're not going to violate any of those clauses and codes because we already identified what the main issue is and the root cause, and we can take the most ethical actions to stop it.
Legal analysis. On this slide, we're going to be talking about the legal concepts. We chose negligence as the legal concept because it is where one party fails to meet the expected standard of care, causing harm to another party. In the Quebec Bridge collapse, negligence is the key legal theory used to establish responsibility for the collapse and resulting damages. It involves proving that the responsible party did not meet the required level of care leading to the collapse. The importance of negligence in engineering disaster has been established by legal precedents. These precedents allow the responsibility of engineers to take reasonable care, the value of professional standards, and the liability that can result from neglect in engineering projects that have catastrophic results. These are the four key tests that we choose: duty, breach, causation, damage, or harms. The parties involved: for the defendants, we have the design engineer, regulatory entities, and contractors. For the plaintiffs, we have the victims and the insurance firms.
Alright, now moving on to proving negligence in today's day and age. As previously mentioned, negligence can be proven through duty, breach, causation, and damages. In our case, Theodore Cooper had a duty of care which he did not comply with. Similar to the 1932 case of Donahue v. Stevenson, where Donahue actually found a snail in her ginger beer. Both Stevenson and Cooper had a duty of care, whether it be in manufacturing or ensuring that the Quebec Bridge was designed, constructed, and maintained in a safe and sustainable order. Cooper breached said duty as he continuously decided not to acknowledge concerns or supervise the construction workers. This ultimately led to the bridge collapsing, tragically losing 75 lives and had injured 11 others. This also caused damage to both property and the economy. Since negligence was proven, the court would decide that Theodore Cooper is liable. He could be ordered to pay compensation for damages caused, such as the harm and losses suffered by the plaintiffs, as breaching his duty is a serious offense that has caused immense harm and signified the importance of duty and ethics to engineers all over the world. Moving on to conclusions and key takeaways.
Overall, the collapse of the Quebec Bridge took 75 lives and injured 11 more by having poor design work with errors in calculations. Another cause of the collapse was engineers ignoring protocols and standards, leading to the breach in the duty of care. To prevent this from happening in the future, engineers responsible for a project should exercise better judgment. Did you know that the collapse of the Quebec Bridge led to the tradition of Canadian engineers wearing iron rings? This symbolizes the humility and fallibility of every engineer.